Projective Geometry, Volume 1, by Oswald, Veblen, and John Wesley Young.
Chapter 8, Projectivities in One-Dimensional Forms. Section 74, Projective Projectivities. Let pi be a projectivity on a line L, and let pi1 be a projectivity transforming the points of L into the points of another or the same line L'. The projectivity pi1 pi1 inverse is then a projectivity on L', for pi1 inverse transforms any point of L' into a point of L. Pi transforms this point into another point of L, which in turn is transformed into a point of L' by pi1. Thus, to every point of L' is made to correspond a unique point of L', and this correspondence is projective, since it is the product of projective correspondences. Clearly, also, the projectivity pi1 transforms any pair of homologous points of pi into a pair of homologous points of pi1 pi1 inverse. Definition: the projectivity pi1 pi1 inverse is called the transform of pi by pi1. Two projectivities are said to be projective or conjugate if one is a transform of the other by a projectivity. The question now arises as to the conditions under which two projectivities are projective or conjugate. A necessary condition is evident. If one of two conjugate projectivities has two distinct double points, the other must likewise have two distinct double points. If one has no double points, the other likewise can have no double points. And if one is parabolic, the other must be parabolic. The further conditions are readily derivable in the case of two projectivities with distinct double points, and in the case of two parabolic projectivities. They are stated in the two following theorems. Theorem 4. Two projectivities, each of which has two distinct double points, are conjugate if and only if their characteristic throws are equal. Proof: the condition is necessary, for if pi prime are two conjugate projectivities, any projectivity pi1 transforming pi into pi prime transforms the double points m, n of pi into the double points m prime, n prime of pi prime, and also transforms any pair of homologous points a1 of pi into a pair of homologous points a prime, a1 prime of pi prime, i.e. pi1 of m, n, a1 is equal to m prime, n prime, a prime, a1 prime, but this states that their characteristic throws are equal. The condition is also sufficient, for if it is satisfied, the projectivity pi1 defined by pi1 of m, n, a equal to m prime, n prime, a prime clearly transforms pi into pi prime. Corollary: any two involutions with double points are conjugate. Theorem 5. Any two parabolic projectivities are conjugate. Proof: let the two parabolic projectivities be defined by pi of MMA equal MMA1, and pi prime of M prime A prime is equal to M prime A1 prime. Then the projectivity pi1 defined by pi1 of MA1 is equal to M prime A1 prime clearly transforms pi into pi prime. Since the characteristic cross ratio of any parabolic projectivity is unity, the condition of Theorem 4 may also be regarded as holding for parabolic projectivities.
Projective Geometry, Volume 1. This book was written by Oswald, Veblen, and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renhold, with programming and illustration by Jim Renhold, 2019. Thank you for listening.